Okay, geometry students, as I was looking at the turn-in so far on the worksheet, I am seeing that some of you have some skill gap with really understanding what volume is asking for. Volume is the amount of space inside of a figure. So I have a few figures here on the screen that are drawn by me. Sorry, they're not beautiful. But when we look at them, we know we're pretty much going to use one of two formulas unless we have that weird sphere that has its own formula. The two formulas we're considering are volume equals capital BH. Remember, B stands for area of the base. Yes, you have to find the area of the base in order to use that piece. And the H is the height of the prism or the height of the figure. The other formula we consider is volume equals 1/3, capital B, or area of base, times height. So we need to decide when we use each one. We ask our question, can we turn the shape in a way that the bottom side would stack up? So if we're looking here at this cylinder, right now it's sitting on its circle side. If I cut out that circle over and over and over again, would it stack up to make the cylinder? The answer is yes. If it will stack up, this is the formula we'll use because we're taking that base, that circle area, and we're just stacking it up for the height. And that will find all of the volume inside. When I look next to it at the cone over here, I'm asking myself, is there any side I can put it on the bottom where it'll stack up? And there's no way I can turn a cone where I could stamp it out and make it stack up because I'm trying to get to this single vertex up top. So if I have that case, then I need that formula with the 1/3 in it because I'm actually removing 2/3 of the volume in order to make it come to a point. So we're going to use this formula for a cone. When I look at the triangular prism here, I ask myself, is there a way I can turn it so that the bottom stacks up? So imagine that it looks like that behind it. So right now it's sitting on a rectangular base, and that rectangle, of course, will never stack up. But could I tilt that tent up so that this triangle piece that's here is not the side, but it's now the bottom? So I just need to imagine standing that triangle up toward me, and then I could stamp that triangle out multiple times in a row, and I can use the formula that the volume is the area of base times the height, where the base is the triangle, and the height piece, once I stand it up, would be this unit there. Then the last one I have right here for you is the pyramid. The pyramid, you still see that vertex coming right there. So we know that we cannot have the full volume, that we've actually removed 2/3 of the volume in order to get it to the vertex. So we're going to use this 1/3 formula. So let's see what that actually looks like with some examples. All right, so if I was looking at a cylinder, let's put a cylinder in and let's give it some numbers to go with it. So let's say that this is 10 centimeters, and let's give the bottom a diameter of 8 centimeters, referring to that right there. So I'm asking myself, will it stack up? We just came to the conclusion that it does. So the formula is volume equals area of base times height. Well, the base that's going to stack up is a circle shape. So I need the area of a circle. And the area of a circle is pi r squared. So I need pi. I need half of this diameter. So the radius is going to be 4. So pi times 4 squared. Sorry, my little 2's kind of deformed there. All right, pi 4 squared. And then the height we're referring to is how high will it stack up. That's going to be that 10 piece there. 4 squared is 16. 16 times 10 is 160. So 160 pi is my precise answer. If I wanted to approximate, I can use the pi button on the calculator. Because I'm working in 3 dimensions, I need a unit that shows I have 3 dimensions, a length, a width, and a height. So 160 pi centimeters cubed would be a good answer there. All right, so let's look at one more quick example. Let's say I have this triangular prism, like a tent. Make it look kind of 3D. All right, and let's say that I have measurements. Let's make it a tent. So this goes back 8 feet. This triangle, the flap here in the front, it's 4 feet. And we'll split that flap there. This is worth, let's go 5 feet. And that should be pretty good for us. So we know now that we need to ask ourselves, will it stack up? In this case, we said the rectangular base would not, but we could tilt it so this tent flap is on the ground. So imagine pulling that tent up, and we can make it follow the volume equals area of base times height. The base in this case, or the side that stacks up, is going to be the triangle. Triangles have a formula of 1/2 little b little h. That's that base side or the bottom of the triangle and the height of the triangle. And then this h is going to be the height of the prism. So 1/2 of 4 times 5 times the 8. So if I can just do the half of 4, I have 2. 2 times 5 is 10. 10 times 8 is 80. So I'm looking at 80, and again I'm in volume, so cubic feet. And of course, if I would have added the point, I'd use this same formula, but I'd be dividing by 3 in order to put that 1/3 in. That's for those cones and pyramids. So hopefully if you're a little confused, you're a little less confused if you watch the video.